Hi there. In this video, we will explore how we can enhance our DBIx result lookup by applying conditions like limiting rows, paginating our items, or specifying which columns we want to select and more. So with that said, let's start by slightly adjusting our example. First of all, let's remove the part where we are supplying the where conditions. As we know, the first part for search result set contained the conditions that we want to apply the where filtering. Now the second part is what we're going to explore in this video. I'm removing everything that came in the first part, specifying the where conditions as on def, and just adding a simple anonymous href as a second argument. Now we're getting all the results in this all array. All I'm going to do is I'm going to say current context of an item I'm going to loop through for all items that we're getting back as results from searching ResultSet node. Now, and here I'm just going to print out the ID because we know that on node we have the ID attribute. Alright, starting with more basic scenarios. Currently, if we run this through Perl, include the library and the script, we're going to see that we're printing out all the IDs in ascending order, so from 1 to 6. Now, what if we don't want to print out all the items, but we want to limit how many results are being returned? Now what we can do, we can use a keyword rows. And rows just specify to the result set of how many items we want to fetch. In this case, we say that we only want to fetch first 3 rows. Now if I rerun the script, we're going to see IDs from 1 to 3. Now that's very simple. The second argument we're going to explore is called page. And page allows you to paginate your results. What I mean by that, for example, if we say that we want to fetch back 2 rows instead of 3, and we want to fetch the first page, and run our script, we're going to see that we're getting 2 items. So 2 result items, and we're printing out IDs here. Now this is because our result is now being paginated, having 2 items in each page. Altogether, we should have 3 pages because we have 6 items. So now if I say, give me page 2, I'm getting items 3 and 4. And finally, if I say, give me page 3, that should be 5 and 6. And this is because we have 6 items in the nodes table. And if, of course, I say, give me page 4, then this page doesn't exist and there's nothing being printed out. Now also, of course, we can add our dbic underscore trace equals 1 to see what is actually happening behind the scenes. And we can see that we're selecting all the columns from node. We're starting after item 6 and asking for 2 rows and nothing exists. So if we go one back and rerun the script, for the third page, we can see that our limit condition says, starting from afterwards the 4th item, give me next 2 items. Here we're getting 5 and 6. Now very similar to rows and page, we can also use offset. And offset is going to be doing the same as combination of rows and page. But here we can, for example, say, give me results with offset 2. If we save this, run the script, it's going to return all the rows after starting number 2. So we have altogether remaining from 3 to 6 items. And then there's a very high number, which is the ceiling limit. And that's how many items you can have in a table. So basically everything after second item, just return me maximum that's possible. Quick note here, you can combine offset with rows parameter to specify how many items you want to retrieve from your result set after the given offset position. The given rows value will override the current default of the second placeholder to return max number of items as per value given in the rows. So you're not limited to only using offset and forced to return maximum items after offset. Now the next one we're going to look at is called order by. And order by, as the name implies, allows you to order your results. Now every single time when you fetch your results, it's going to return them in ascending order, so from lowest item to highest. Now we can change this order by saying order by. We provide direction. Let's just say that we want all the items ascending, which is already the default, and we can specify which fields we want to order by. So if we say ID and run the script, it's just going to return all the items from 1 to 6 in ascending order, which is the default behavior. We can also say return me items in descending order. So now we're getting back items from 6 to 1. So from the end of the table to the first item. And you're not limited to only ordering by ID. You can supply multiple values here, how you want to order your results. For example, you can say order by user ID, and you also want to order by ID. So if we save this, run the script, we're going to see that now we're getting order by user ID descending and ID descending as well as the second argument. So what we provided here. So user ID first and then ID. We can also group our results. So using keyword group by, we can impose grouping to our results. So let's say we want to group all the results based on user ID. So if we save this, oops, so group by doesn't have the descending, so let's remove that. And also we don't need curly brackets, so let's amend that and run the script again. We're still going to see an error, and that is not really down to DBIx, but the issue is with SQL, where we say that we want to group by user ID, but we're selecting all the columns from the database, which doesn't really make sense. So when you use group by, you should also specify directly which fields you want to select. And this brings us to the next argument that you can use, which is called columns. So if you use columns, you can specify which fields exactly you want to select from your result set. So in this case, we can say we want to select user ID and we want to group by user ID. So if we rerun this, we're going to see that it's executed fine. Of course, we're seeing warnings now because we're only selecting the user ID, but when trying to access the ID, so this ID, it does exist as an attribute on the node result, but it's not initialized because we're not selecting value from the database. So what we can do, we can replace this with user ID because this is what we're selecting, and we're getting back 1 and 2. And we're getting back 1 and 2 because we're saying we want to group by user ID. So we have 3 user IDs. Well, we have 3 nodes with user ID 1, and we have 3 nodes with user ID 2. So if we group them together, they're going to be only 2 unique items, which is user ID 1, of course, and the user ID 2. And as before, you are not limited only to group by one field. You can add more fields, such as ID, and we can add ID here as well and rerun this. And now, of course, we're just getting back all the results as before. So if I replace this with ID and run the script, we're just going to go from 1 to 6. And this is because, of course, if you're grouping by ID, then by the end of the day, all the items are unique. Now let's explore the columns in a bit more detail because there is more than meets the eye. So this is the simple form you can use when calling columns. You can say that instead of invoking the default result set behavior, which as we have seen before, that selects all the columns from the table, you can say that give me only the user ID and the ID as such. But you can extend columns by specifying unique names of how you want to select these columns, and you can also apply functions in raw SQL to add your own unique columns. What I mean by that, I could for example say test and have this as an alias to user ID. So in this case, in order to do that, I want to use a string reference, so backslash and 2 quotes, and I can say user ID. If I save this, run the script, I'm going to see a bunch of warnings because of course again we're not selecting ID anymore, we're only selecting user ID. But now, for example, if I try to use the user ID, save the script and try to run it again, you're still going to see that this is initialized. And the reason is because when we're using alias such as test for a user ID column is not populated. What actually happens is that this value is stored on the result item, which is accessible using getColumn method. So if we call getColumn and provide the alias that we used, in this case test, and run the script again, we're going to see that we're getting 3 user IDs for 1 and 3 user IDs for 2. And again, this is what matches in our database. And again, when you're providing backslash to string, you can provide anything what you want in your string reference, such as you can, for example, say that you want to select a hard-coded value, such as I am a test. So if we save this, run the script, you're going to see that we're selecting I am a test from the node table. So this is our custom value that we're selecting from the node. And you can also use placeholders when using columns and aliasing a value. For example, we could use a reference to array reference. We can provide or query, such as if you use a MySQL function, let's say if user ID, and we can say it's larger than 1, then we can say yes, otherwise we're going to say no. And of course, this wouldn't be very useful example if we provided a hard-coded value here. So we can just replace this with question mark. And the second argument we can use in our array ref, we can provide a value that's going to be injected in our placeholder. So now, if we run the script and observe the results, we're selecting a function that says if user ID equals larger than the given value, then have this column as yes, otherwise have it as no. And we know the first 3 items have a user ID of 1, so that's going to be no. And the remaining 3 have user ID of 2, and that's larger than 1. Now, very similar to columns, we can also use plus columns. So the same name, it's called columns, but you just add plus in front of it. And you want to quote this, so Perl doesn't interpret it as an actual plus before the bare word. So what a plus does, it's the same as columns, but instead of overwriting the main selection of the columns, it just adds additional columns at the end of our selection. So here we can say, for example, I want additional column, which is called test, and I want this column to contain a simple value such as a string, So let's use quote, and I am a string. If we save this, run our script, we're going to see that now, by default, we're selecting all the columns that we have in the node table, and we're adding additional column at the end, which is our test value. Now again, it works exactly as columns, but it just doesn't override the default selection. And you can use all the specific types of how you want to select your columns, as we saw before, such as placeholders or direct values, or just a simple form that you want to add more extra values of the default selection, such as we could say that we already are selecting user ID, but we also want the user ID again, so user ID here. If we rerun this, well, it's not actually going to add anything because we're already selecting user ID and it's smart enough not to add it at the end. And of course now we're getting a warning that no such column test exists anymore because we removed the test alias before that we were using for columns. So the next argument we're going to look at is called select. So if we say select, so select and provide array ref, the key thing about select is it's pretty much the same as columns. There's not much difference. The only specific about select is that when you use columns, the key in your left-hand side is going to be your value alias. And what you have as a value in your hash ref is going to be the value you're selecting. With select, you're only selecting specific values. It doesn't automatically alias what you're selecting. So what I mean by that is, again, if you explore the simple form, you can say only select user ID and description. So now, of course, we don't have the test column, so we can just say print me all the user IDs that we're looping through and save this, run the script. We're going to see, again, we're selecting only user ID and we're selecting description. So very similar as we had with columns. Now, if you want to alias these columns, you need to use additional keyword such as. So you can say that you want to select user ID and description as test1 and test2. If we save this, run the script, again, we're going to see that the current user ID attribute we're trying to print is not initialized because we're selecting user ID, but we're aliasing it as test1. So what we need to do, we need to use get column, and here we provide test1. Save this, run the script, and it's going to work fine as before. Or if you're saying that we want to select test2 as our aliased attribute, it's going to do just that. As I mentioned, this is the simple form of how you can use select. There are a couple more specifics of how you can enhance it. For example, you could use a function such as count. So you want to count all the user IDs in the table and you want to alias that as test1. So if we save this and replace this with test1, run the script. So we're going to see in the SQL that now we're applying the count function to the user ID. So it might be a little bit confusing because when we used columns, the key was the actual alias, but now we are applying SQL function using the select keyword. And yet another note here is that you don't need to use the as keyword as an additional argument here. You can also say minus as and then test3 for sake of example. So now we can alias this column being selected as test3 inside our select statement. So if we run this, we're going to see that it still print out 6. And it's also adding this as keyword here. Now the difference here is that if you want to extend your SQL and do additional query using that alias as test3, you can do it directly in the query. As if we look at previous examples where we were using the as keyword as a separate argument, it didn't provide the alias in our query. So that alias that we used before was only initialized on our result item, and we got it through using getColumn method. So again, note here, if you want to use your alias on a column at the time when you're building your SQL in the result set, you probably want to use this syntax, which is minus as, and then you provide the name for the column. Now, one more last thing about select, you can also nest your SQL conditions. For example, you could say, give me max length, and we're wrapping around length with max, and then we can specify columns such as description. And here we can also alias this saying minus as and test3. Save this, run the script. We're now going to see that we're selecting the max length of description as test3. And we're printing it out here, which is our only select column because we're using aggregate function. So there's going to be only one item and the value is 17, which is going to be the max item from the node description, which, well, pretty much is the same length for all the node descriptions. Now where this becomes useful, as I mentioned using the alias inside the query, is that since we're using aggregate function, we can't use the where condition anymore. We need to use the having function. So if I just clean this up a bit, and now, for example, I would like to say that we're selecting the max description and we want to return all the results having, this is the new keyword, a value, for example, or test3 that is going to be larger or equal to, let's say, a value of 15. And here we actually need to wrap this around curly brackets, such as this. And if we save this, run the script, looks like we're actually getting an error. And let's see what this is all about. All right, so it says unknown column test in having clause. Well, of course, because we're actually naming our column test3. And that's how we want to name it using the having condition. If you rerun this, we're now going to see the same condition, which says, give me the max length of description, aliasing this as test3 from note, where having test3, which is the length of 17 in this case, larger than 15. And we're getting back one result. And of course, if we increase this to 18 and rerun our script, we're not going to get back anything because there are no descriptions that are currently larger than length of 17. Now going back to the previous example, so if I would remove the -as keyword here, and I would introduce it as a separate argument, such as this, so test3, rerun the script, you're going to see that it throws an error. And this is what I was talking about, because now when we're selecting our aggregated value, there is no alias. The SQL cannot reference it using the having clause. This is going to be returned with the key as it is. And if we say having test3 larger than 18, there is nothing that references this test3 name for this column. We still have it in our get column result. That's fine. So for example, if I now remove the having clause and rerun the script, it's still there. But again, the difference is that we don't have the actual as alias in the SQL, so we cannot apply the having condition there. We only have the alias of test3 on our result set. So this might be a tripping point, and you need to watch out for this. And if you're using select, this is one way how you can avoid of not having the aliased columns. If you still want to use columns and you want to have an alias, you can manually supply that alias, meaning you can say columns, and we use arrayref, and let's call this test3, and we can say that we want to reference a raw SQL, which is going to be, in this case, we need to provide it by hand. That's going to be max length, and then it's going to be description, and here we need to supply the alias test again. So if we save this, and this is actually test3, so test3, not just test. So save this again, run the script. Oops, something isn't quite right. So it says there's a syntax error. Yeah, so it looks like we added the ending bracket too soon. So this is of course because we're wrapping the description around the first function length, and then we're wrapping the max. So we want to alias the outer function as test3, not the inner function. So if we save that, run this again, and looks like we're still getting an error. It's not my lucky day. All right, so it says trying to select me test3. All right, of course, yeah, we need to use a hash reference here. So it's not a simple form. We're actually providing the key as an alias on the left-hand side and then our expression. All right, so third time the charm. If you run this, this looks good. And as you can see here, we are supplying now the as alias in the SQL. And if we would use the same having function as we did before with select, having test equals or larger than 18, we run this again. We're getting no results. And of course, if we say that we want larger or equal to 17 and run this, it's going to give us one aggregated result. All right, I hope this is not too confusing, but the key takeaway is that there are subtle difference between select and columns, but the biggest difference is that when you're using columns, you can just alias your columns as a key and then provide the function on the right-hand side, but you need to do it by hand. Now, if you do select, then you need to use the as keyword because you cannot alias your selected items as a key. And with select function, you can also use MySQL functions such as max, length, or so on in this format as we did here. And yet another difference is that if you're using -as in the column that we're selecting, then that's going to be applied as an actual SQL as alias in the query. I really hope this makes sense. So that's about it when it comes to select and columns. There's still some conditions I would like to explore. Let's go back a bit. And when we talked about grouping, we said that we can group by specific fields. So we can group by user ID, but of course then we know that we need to select specific columns, which are user, so user ID here. And we also want, of course, use the user ID for the grouping. So if we save this, rerun the script, and of course we're missing the arrow notation here, so rerun this again, and we can ignore this error because we don't have test3 anymore. But instead of using specific grouping on items, you can also use the keyword distinct, and distinct is going to apply grouping to all the fields that are being selected. So here I'm going to remove the get column. So I'm going to say, just give me the user ID, save this, run the script. You're going to see that we are selecting user ID, and it automatically, the distinct keyword automatically applies grouping on user ID. The same thing if we say description, that's what we're selecting, and we're using distinct, it's automatically applying grouping on description. So that's kind of a neat way to reduce the need of specifying the fields you want to group by, because if you're using distinct, the grouping is going to be applied to specific fields that you're selecting. Now we can also remove, of course, columns, and we know that by default from our result set, we're always going to get back the same columns. If I run this, we can see that all the columns are selected and also all the columns are being grouped by. There are two more keywords I would like to look at. So one of them is called for, and you can use for update. So if we set the for and save the script, rerun it, we're going to see that our SQL statement looks like this. So we're selecting all the columns from node for update. And the for keyword, it's really SQL specific, but what it basically does is when you're selecting from a table like nodes and you're adding for update later on, what it does, it locks all the rows in that table until an update statement is executed. So basically that means that every other connections wanting to query for the data needs to wait for update statement to execute. So it's always getting back the latest data. But that's really SQL specific, and we don't need to go into that too much. It's just good to know that if you know what is for update, then it's a neat way how to specify it in the second argument list in the search result. Now the final keyword I would like to look at is called cache. And as the name implies, it allows you to cache your results that you're selecting. So we can say cache and provide value 1. But we're saying to the result set we would like to cache our selected results. And how it works is that let's change this variable to result set. So let's not invoke a result set. Let's just construct it by saying cache 1. And we can also say that we want to select columns, which are going to be ID and user ID. And now let's execute our result set twice in a row. For example, let's say first, and then if we copy this, let's just copy this 3 times. By default, we would expect to see that we are constructing a result set where we are selecting ID and user ID. Then we're invoking that result set 3 times, right? So we should see 3 SQL queries. Oops, and looks like I left the all keyword here, or maybe not, looks like we just forgot to save the script and rerun it again. And what we're getting back are the hash references. So because we are getting back result item, and what we actually want is, let's say we want to print out the ID, not the instance of result, which is a reference in memory. And if we rerun this again, we're going to see that we're getting back 3 ones. So we're getting all the nodes, we're only getting the first result, printing the ID. But the interesting part is that we would expect to see 3 SQL statements being ran, but that's not really the case. Looks like the SQL statement was ran only the first time. And this is because we're using cache. So we invoked the query in our result set, fetched the ID, and printed out. And for the remaining 2 result set invocations, we didn't run the SQL. So if I remove the cache, just to show what I mean, and run this again, we're going to see now that for every single time that we invoke the result set, we are also executing the SQL. So that's what the cache keyword does. And it's specific to how your SQL is built. What parameters are you providing? So in this case, if you're using cache and saying, I only want to select the ID and user ID on the same result set, it's going to be smart enough to just return the cached values. Alright, so that's it for this video. There are a lot of things that we covered here. We explore conditions of how to limit all rows, using offsets, order by, and probably the biggest part is the columns and select. I hope this wasn't too confusing, and I also hope you found this quite interesting. With that said, I'll see you at the next video.